Good morning. Today I'll be going through the questions that we have not gone through yet in your forces worksheet. So please make sure you have your forces worksheet with you. And please ensure that you have already completed the SLS before we go through this worksheet, because we will also be covering content that we have covered in the SLS for today. So please make sure you've completed this worksheet before watching the video. We've gone through all this. It's only question 5 of the true and false, which we have not gone through yet. So the larger the surface area in contact, the larger surface area, the higher the pressure. This is not true because based on the equation, FPA, there's a larger area, the pressure experienced should be less. So if you don't really agree with it or not convinced, you can just put in arbitrary numbers. Okay, let's say the pressure is 10 pascals, area is 10 meters square, the force is 100 Newton. The larger the surface area, higher pressure. So let's say for surface area of 10 meters square, the pressure is 10 pascals. For the surface area of 100 meters square, what is the pressure? Pressure equals to force over area, 100 meters square. You will realize that the pressure will only be 1 pascal compared to 10 pascals. Okay, so the larger the surface area in contact, the lower the pressure experienced. So this sentence is false. Please mark your MCQs. We've already gone through question 1 to 6. So we'll be going through question 7 to 10. Question 7. Which of the following correctly describes the relationship between force, pressure, and area? So you must know this triangle very, very well. If you don't know it well, you apply the wrong formula, then you will not know what's going on and you get the question wrong as well. Okay, so please know the units for force, Newton. Normally it's in meter square, but it can be in cm square as well. Pressure is in Pascal. Some people write it as Newton per meter square is also acceptable. Okay, but to make things simpler, you can just write Pascal. What's the relationship between force, pressure, area? The larger the area, the higher the pressure. Okay, we just proved it above that it is not true. The larger the area should be the lower. Okay, so 1 is false. The larger the force, the higher the pressure. That is true. Ensuring that area is kept constant. If we increase the force, the pressure will also increase. Alright, so this is true. So if you don't believe me, you can go and substitute. Number 10, 10, and 10. The larger the force. Okay, so now pressure is 10 pascals. I change my force to 100 pascals. Okay, we have 10, 10, and 100 newtons. So right now my pressure is 10 pascals. If I change the force to 1000 Newton instead of 100 Newton. So 1000 divided by 10 meters square. My pressure will be 100 pascals. Okay, so we can tell that yes, the pressure will be higher. Pressure equals to force divided by area. That is true based on the triangle. Answer should be 2 and 3. Okay, answer should be C. for question 7. Let's move to question 8. Which of the following scenario would the most pressure be exerted? So I'll need you to calculate using this formula. Okay, calculate by yourself. You will realize that the scenario which has the most pressure being exerted would be D. Okay, so I'll just do one sample for you. Cutting a block of cheese with a force of 200 Newton, you just take 200 divided by 0.10 meter, 0.10 meter square for A. Okay, for A, then you do the same for B, C, and D. Then you compare. Question 9, the diagram shows a block exerting a pressure of 60 newtons per meter square on the floor on Earth. What is the mass of the box? So, we've learned that 1 kg equals to 10 Newton. We know this formula as well, okay? To make things easy, we always write out the formulas that we know already. What is the mass of the box? So, let's see. The pressure, we know already. Okay, in order to find the mass in kg, we will have to find out how much pressure it is being exerted. So I will know the force. We already know the pressure. Okay, so from the pressure and finding the surface area that the box is exerting on the floor. Okay, finding the pressure that is exerted on the floor within this surface area, I will be able to find what is the force exerted downwards, okay, which is affected by gravity. And then from here, I'll be able to convert this to kg. So first, let's find the area equals to length times breadth, 12 meters square. So that's step number 1. I found this. Okay, now I have the pressure. Now I have the area. I can find the force which the box is exerting. I just need to take pressure times area. 60 times 12 equals 720 newtons. Okay, this is the force which I have just found out. And now I want to convert it to kg. I just need to divide by 10. So divide by 10, I will get A as the answer. Okay, so we have to do step by step. It's not straight away we can find the answer. Next question. During a baseball game, pitcher throws the ball with a force of 600 newtons, distance of 200 meters. So in this case, I'm using my DST triangle formula instead. Speed of 4,000 meters per second. Okay. What is the time taken for the ball to travel 200 meters? So the question gives you the distance, okay, and it gives you the speed. Ball travels at a speed of 4,000 meters per second and travels this 200-meter distance. So how long does it take? Distance divided by speed. to give me time. So distance divided by speed okay. Then you divide 2/40 and eventually your answer should be 8. Okay. This is distance divided by speed. Alright, we've already gone through question 1 and 2. Let's move on to question 3. Figure 3.1 shows two nails A and B, same mass. Okay, so example, both of them each weigh 1 kg. So 1 kg constant. Okay, which nail will penetrate? Well, it's quite obvious. It'll be A, right? See, it's so sharp. Okay, and you will need this formula thing as well. Alright, the smaller the surface area, the higher the pressure. Force is the same because the mass is the same. Okay, so I'm sure you can tell that the answer is A. So why? So you cannot just say, oh, the answer is A because the smaller the surface area, the higher the pressure. Okay, you see this kind of answer, you are not applying your knowledge, you're just memorizing and regurgitating. You need to have the explanation with regard to the question. So you must say it has a sharper tip compared to B. Okay, then you can apply the concept here, which means A will have a smaller area in contact with the wall. You need this to get a mark compared to B. See this one? Larger surface area, this one smaller. In contact with the wall. Alright? Then now you can bring in the concept. Since pressure is the force over the area in contact, the wall and the force is the same. Okay, since they're the same mass, nail A will exert a higher pressure. This is how you explain, therefore allowing it to penetrate the wall more easily. So your answer has to be explaining with regard to the nails. Okay, you cannot just tell me a very general answer like the higher the surface area, the smaller the pressure, the smaller surface area, larger pressure. Okay, then I'll say question mark and put its arrow. So why? How is it related to the nails? Then you must explain. B. Snowboarder has a weight of 650 newtons. He puts on his snowboard, which has a total area of 0.5 meters. So I advise every student to always draw this triangle. Because some of my students, if they don't draw, they always forget or make careless mistakes, then they calculate wrongly. So always draw the arrow to be safe. Okay, so 650 newtons, 0.5 meters squared. Okay. Wait, this one is just the snowboarder. You must plus the snowboard weight as well. Okay, then the pressure will be 1400 Pascal. So how to calculate this unknown here? This is very mathematical, okay? So if you're good at maths, you should know how to do this. So I know the pressure, I know the area, I can calculate the force of both the snowboard and the snowboarder. So first step, we must show this. Please write the formula. Okay. And the weight of the snowboard, you just need to take snowboard plus 650 Newton, right? The total weight minus the weight of the snowboarder. Then you get the weight of the snowboard. Don't forget your units. If you forget your units, minus mark as well. Next, figure 4.1 shows two identical 20-cent coins, each being pushed into each piece of plasticine. So they already said here it's identical, so the mass is same. That means the weight is the same. That means the force exerted by both will be the same. You can tell here already, right? Smaller surface area, higher pressure here. So obviously the answer is B. Why? You have to know how to explain properly. So you must talk in relation to the question. Don't give me general answers. If you say smaller surface area has higher pressure, therefore the answer is B, then you cannot get a full marks already. Alright, you have to explain there's a smaller surface area in contact, okay, with the plasticine. Then you have to explain since pressure is lesser with high surface area, or if you say since pressure increases with decreasing surface area also can, then the coin in B will exert higher pressure, resulting in a deeper dent. Right, both also can. Calculate pressure exerted. Draw your triangle. 100 newtons and 0.05 meters squared. So just take 100 newtons divided by 0.05 meters squared. Then you get your answer. Please include units. Alright. Question 5. Figure 5.1 shows a diagram of how car brakes work. Brake pedal is connected to a piston A, okay, which pushes in cylinder C, which is filled with oil. Okay, so I think this thing here is the piston. I'm not sure how come here they never label. Okay, so it's being pushed. Right, this is the piston. It pushes cylinder C, okay, which has oil. Driver's foot presses on the brake pedal, causing this piston to exert a force of 640 newtons on the oil in cylinder C. The cross-sectional area of piston A and cylinder C is 2.0 cm squared. Okay, so they are saying this surface area in contact. Let me just use a different color, maybe it'll be clearer here. Okay, the green color here is the cross-sectional area of piston A and cylinder C, which is 2.0 cm squared. Okay, let's change color, purple. Calculate the pressure exerted on the oil. So we are not doing anything new here. We are still applying this formula. What's the pressure on the oil due to the force on piston C? So they already tell you the force is here, okay? 640 newtons. And the surface area here, the star here, is 2.0 cm squared. Alright, but since you have to express your answer in Pascal, and we know that Pascal is Newton per meter square, we have to do an extra step here to convert cm square to meter square. So to convert cm square to meter square, I have to divide by 10,000. Alright, then you'll be able to convert. Then this will be your answer, please. mark your work, check it, do corrections. You may pause the video at any time if I'm going too fast, okay? The cylinder at the brake pedal is connected by pipes containing oil to cylinders at each wheel. Okay, so figure 5.2 shows cylinder D and piston B at one of the wheels. So cross-section area is the same idea here. It's where the piston is in contact with the oil in cylinder D. So pressure of the oil on piston B is the same as pressure on piston A. So we know that the pressure we found already on top here. Okay, I'm circling it now. Without calculating the force acting on piston B, so you don't need to calculate, you should already know, okay? Without calculating the force acting on piston B, determine whether piston A or B has a greater force acting on it. Okay, so without calculating, you should be able to tell that okay, you can see both answers here. B has a greater force because they have the same pressure. Okay, so pressure is the same, only the surface area is different. Okay, so to make things a bit simpler, let me just show you using simpler numbers here. Alright, for piston B, let's let it be the one on the left. Piston A will be the one on the right. So we know that they have the same pressure. So let's say this pressure is 10 pascals. 10 pascals. Okay, then we know this one is 10. Let's say 10 meters square, for example. For piston B, it has a 15, okay, larger, 100 meters square. Okay, so in order to find out whether which one has a greater force, I think if you don't calculate, you can still be able to understand. Okay, in order to get the same pressure, alright, I cannot have the top two numbers being the same because the bottom numbers are different. Alright, so this one is 100 divided by 10. This one, you want to get 10, right? 100 divided by 10 equals to 10. 1000 divided by 100 equals to 10. Okay, I know this one, I'm showing you simple calculations. Okay, but this question does not require you to calculate. But if you need to, you can secretly go and calculate on your own. Then you'll be able to see that in order for it to achieve the same pressure, if you have a larger surface area, we already know that larger surface area, pressure is lesser. But I want the pressure to be the same. So to compensate for that lower pressure, I'll have to apply a greater force so that I can get the same pressure as piston A. Okay, so your answer, explanation is here. Since pressure is the same, if there's a larger surface area, you need a larger force to be applied in order to get the same pressure. So it has to balance out, as I have shown you using these two examples. Next, when a car brakes on a slope, it remains stationary. Why? Friction. Okay, friction or frictional force by the wheels on the slope prevents the car from sliding. What will happen? The car will roll down because the Earth's gravitational force is pulling it downwards. I think this is a simple question. By drawing a suitable diagram, making use of our knowledge, explain how we are able to suck liquid from a bottle using straw. So this one has to do with atmospheric pressure. Okay, so this question is more demanding. You have to draw and you also have to explain the drawing. So when you suck the straw, there's fewer air particles here. Okay, so the pressure is also lesser inside here where your mouth is inside the straw. Okay, this thing here is your mouth. So there's lower pressure here. And there's a higher atmospheric pressure outside. So we always know it's from higher to lower, right? Most of the time, you see in osmosis, you see in diffusion, you see in heat. Okay, more heat to less heat, high temperature, lower temperature. Okay, here same thing, high pressure to lower pressure. So the atmospheric pressure, higher pressure will push the water downwards and will push the liquid up into the straw. Therefore, you're able to suck liquid from a bottle using a straw. And last question, question 7. Common school bag with 2 bag straps. If you design a school bag, will you make the bag straps wider or narrower? So if you're not sure, you go and carry bags with very thin straps. You'll notice after a while, your shoulders will feel very painful because this is biting into your shoulder flesh. Okay? Because we already learned smaller surface area, higher pressure. Okay, that will be very painful. So we will want wider straps. Most of your school bags have very wide straps, which is comfortable. Why? You see, you explain. The wider the strap, the larger the surface area in contact with your shoulder or body. Okay, this will result in lesser pressure being exerted on your shoulders. Therefore, it will be more comfortable. Okay, that's it for this paper. If you have any questions, please ask me. Thank you.